All right, welcome back. In this video, we're going to be talking about how to read a transit schedule. Now, we'll primarily discuss reading paper schedules as opposed to online schedules, primarily because paper schedules tend to be a little bit more complex, whereas online schedules are a little bit easier to intuit in terms of their layout. But you'll still see a lot of commonalities between paper schedules and online schedules. So first, let's discuss the components of a paper schedule. Primarily, you'll find three things. First, you'll find the blurb. So the blurb is a section of text that contains information about how to ride transit. For example, it might detail the fare policy, what holiday service is like, how to contact the transit agency, and a diverse array of information. So this section might be helpful to consult for other issues, but it's not our focus today. For example, if you look on the top picture, the top picture indicates the fare and transfer policy of the MTA, which is an example of a blurb. Next, we have the map. So as before, when we learned about route maps, schedules actually usually include the route map and or the primary location where the route map can be found. On the bottom left, you'll see a route map for a subway line, particularly the C. You'll see a lot of the same elements that we discussed when we tried to read route maps. For example, we have transfer points. We still have stations in this context. We have an order of stations. We have a lot of the same elements that we saw before. And lastly, the part we're interested in this video is the timetable. So the timetable details all of the individual trips on a certain route during a certain day. And also it gives any sort of particularities or any sort of stipulations or exceptions that a certain trip might have. If you look towards the bottom right, that is an example of a typical timetable layout, and we'll kind of, in the next slide, understand how to actually read it. So when we read timetables, we have to understand a lot of different concepts to be able to derive as much information as possible. So the first concept is the idea that there are different levels of service, which means that transit comes with different frequencies at different times of the day. And so those are given by the designations of peak, off-peak, evening, and early morning. So peak service is a heightened level of service. So transit comes more frequently during the rush hour. So both the morning rush hour and the kind of afternoon rush hour. Some routes are peak only, which means that they only operate during these peak periods or these kind of rush hours. Off-peak, thus, is times that are not during the peak periods or during the rush hour. This is primarily during the midday, so the late morning or the early afternoon. Of course, this service is less frequent, so a transit comes less frequently during off-peak times. Evening and early morning service are kind of inverses of each other. So evening service basically occurs around essentially after the afternoon rush hour. And the idea is that people will ride transit less and less as the night progresses. So therefore, buses or any form of transit will come less and less frequently further into the night until transit service stops altogether. So that's evening service. Early morning service is kind of the inverse, right? It starts at the start of the service day and slowly ramps up to the peak period or the rush hour. And the assumption is that more and more people will ride transit as the morning goes on and eventually morphs into the peak period. We also have a distinction between weekday, Saturday, and Sunday service. So essentially, transit agencies operate different levels of service depending on which day it is. Peak service And peak-only routes are primarily restricted to weekdays when rush hours are kind of a relevant idea. And weekday service is also usually more frequent than Saturday or Sunday service. And similarly, Saturday service is often more frequent than Sunday service. Some transit agencies, especially smaller transit agencies, might not run Saturday or Sunday service at all. And that's just kind of how their transit system works. When we're reading a timetable, we also want to understand the direction, right? So for every route, there are generally two timetables, one for kind of the outbound direction, and then one for kind of the inbound direction. And we just want to make sure that we're referencing the correct timetable for the direction of travel we want to go in. Headways. So initially, right, if you look at a transit schedule, it might seem really daunting with all of the numbers and kind of times. But one way that we can rationalize or kind of understand how frequent transit service comes is through the concept of headways. And so headway is essentially the length of time between one bus arriving or one transit vehicle arriving and the next transit vehicle arriving, right? So if we can try and define some of these regularities, transit schedules become a lot easier to comprehend. So just an example, a route with 15-minute headways could have arrivals to a certain stop at 7, 7:15, 7:30, and 7:45. And when we're measuring headways, we want to measure at the origin terminal, if you remember that concept, because that will provide us kind of with the most accurate measure of headways. Time points. So the idea of time points is, so time points are instituted by transit agencies essentially as checks that transit operators don't run too early, right? So buses run on time essentially, or transit runs on time essentially. Sometimes these time points will be where transit operators actually have to physically stop and wait until the time listed on the schedule. But other times, somewhat confusingly, these time points will be estimated, where where transit operators don't actually have to stop. It's just kind of for your own personal reference. And the relevance of time points isn't necessarily to talk about the nuances of the transit agencies, but to give you an option when the particular times that a transit vehicle will stop at your particular stop are not published, right? So the idea is that if you can know the time point before your stop, so the published time point before your stop, and the published time point after your stop, you can kind of figure that the transit vehicle will arrive somewhere in the middle of the stop before and the stop after, right? And so that can give you a rough estimate. And of course, if it's not clear, it's always best to arrive a little bit early to your stop. With timetables, we also have to mention kind of two intricacies. That's with combined schedules. So a combined schedules is basically a schedule, a unified schedule for multiple routes, right? So usually you'll think of one schedule per route, but this is where a bunch of similar routes share a schedule. And this primarily occurs for a few reasons. First is if a route is a express or kind of peak only version of another. So if we have one route being local and then one route being express, making fewer stops in the local route than they could be in a unified schedule. Routes could also be linked, and that's why they have a combined schedule. Or maybe just these routes, like for example, 2 or 3 routes have substantially similar routing for most of their pathway, except for kind of maybe a little bit at the end or maybe a little deviation here or there. And this is kind of important if you see a combined schedule to ensure that you are taking the right trip, right? And ensuring that that trip will actually get you from your origin to your intended destination. The last thing is with the exceptions. So this is kind of the particularities of each trip that we discussed in the previous slide. And the schedule usually will note if there are any sort of exceptions or kind of intricacies to a particular trip. And that's usually denoted, for example, by a superscript or a subscript. And if your trip is affected by that kind of exception, you might want to take note of that if that's something that maybe will affect your itinerary. All right. So now we're just going to observe an example. So this is a combined schedule for the WMATA, so that's the transit agency in Washington, D.C. This is a combined schedule for the 7A, F, and Y. So if you remember the combined schedule, they have substantially similar routing in this case. That's why they're combined into a single schedule. We observe that this schedule is in the northbound direction, as it indicates on the top, northbound to Pentagon Station and Farragut Square. That's our direction of travel. We know that this is a weekday schedule because it says Monday through Friday on the top as well. And we can assume this is an early morning merging into peak service, kind of the morning rush hour time. We see some indications of that. For example, the label AM service. Just a quick side note, when you're reading the schedule, most of the times there won't be an explicit label of AM or PM. There will just be kind of a division between the AM or the PM. For example, here where it explicitly says AM service, or for example, by some sort of formatting like a bolding or an underlining or something like that. We see different terminals. For example, we have Lincolnia Road and Quantrill Avenue, or Farragut Square, or the Pentagon, or something like that. We also see the stops not served. So this is kind of the idea of an exception by an individual trip marked by that kind of hyphen. For example, the first 7A doesn't serve Constitution Avenue and 22nd Street Northwest or Farragut Square. The time points are, of course, the stops listed in the middle. For example, Mark Center Transit Station or Shirlington Transit Center. If we wanted to measure the headways, if you remember, we're measuring the headways at the origin terminal. So we would see that the 7A and the 7F generally have 30-minute headways. So if we want to primarily look at the kind of peak, more towards the peak hour, if we measure the headway between the last 7A on the screenshot and the second to last 7A, we see that the times are 6:41 and 7:12, which is approximately 30 minutes. And if we wanted to measure that of the 7F, we would see that the last two are at 6:53 and then I think it's 7:21. And that's also approximately 30 minutes as well. If we wanted to measure the headway of the 7Y, we'll take the last two trips and we'll take the last two trips and those will be departing from Southern Towers. And for the 7Y, we see for the last two trips, it's kind of a 20-minute headway throughout the span of surface. So that's kind of this video. I hope you enjoyed it, and I hope you come back for the next video, which will be about how to kind of leverage all this information and actually apply it to riding transit. All right, thank you.